use variation of parameters to solve the given system. So here the step to use parameter method. First find homogeneous part, then find non-homogeneous part and add them together. That gives you final answer. Okay, so here's the steps in. It's not a detail, it's not step-by-step process, but I will walk you through a step-by-step. Okay, let's put this aside. Now the first step is to find a minus lambda I. What is it? What is a? A is, let's call this matrix A and then subtract it with lambda I. That gives you this matrix. And then you need to find the determinant of A minus lambda I, which gives you this one. Set it equal to 0, solve for lambda, you will get complex eigenvalues. For lambda equals 1 plus I, plug it into this matrix. It gives you this matrix augmented with 0. Okay, from the first equation, I know that negative I k1 equals k2. If I choose k1 1, then k2 is negative I, then vector k is 1 negative I. Again, you have eigenvalues, complex eigenvalues, so it's not necessary to find lambda equals 1 minus I, because the answer is just the conjugate of each other. Here's what I mean by conjugate. So once you know the first equation, the first solution, you can find the other solution very easily. So x of h equals c1 times. So the real part of k, vector k is 1 0 times cosine t. So this really is cosine 1t y1. This one comes from the imaginary part of lambda. Okay, and then minus imaginary part of vector k, which is 0 negative 1 times sine t, or multiplied by e to the t. Why e to the negative t? Because there's actually e to the positive 1t. That one comes from the real part of lambda. Okay, and then once you know the first solution, your second solution is just a duplicate of the first one, but you need to change something. So first, for this one you have negative side, for this one you need to have positive side. Cosine and sine stay the same, and for these two vectors you swap their position. Okay, then your homogeneous solution is equal to c1 times vector. Okay, so this one is just a simplification of this one. So if you multiply this in and then do some add or subtract them together, it gives you this. Same thing over here, it gives you this one. That's for homogeneous part, that's easy. Now for non-homogeneous part, similarly like a minus lambda I, first put homogeneous part into a matrix, which I call function phi of t. Okay, so exclude c1, c2, put the rest into a matrix, and then phi is determinant. It gives you negative e to the 2t. Then phi is inverse, which is equal to 1 over the determinant times this matrix, but you need to change something. For the upward diagonal line, multiply by negative 1. Downward diagonal line, you switch their positions. Okay, after doing that, it gives you this matrix. The next step is to find u prime of t, which is equal to inverse phi of t times f of t. So you have this expression. Okay, and my caution for you is do not switch the order here. It matters. Why? Because when you multiply matrices together, 1 times a times b is not the same as b times a. Keep in mind that. So doing this, it gives you this matrix. After that, you need to find the integral of this matrix, which gives you u of t. Okay, so this is very easy, very straightforward integral, so I'm not gonna spend time on it. Once you know u of t, your non-homogeneous part is equal to phi of t times u of t. Multiply them together, it gives you this matrix. Again, do not switch the order. I repeat this many times. Okay, hope it sticks in your mind, or otherwise you will get a incorrect answer. Or if some of you switch the order and then get different answer and ask me why they got different answer, Well, it's just a property of matrices, and I can explain it. Okay, I can, but it's gonna be long, and you have to use a lot of demonstration, a lot of proofs. Okay, just ignore it. Now when you get this one simplified, you will get this. So here's a trig identity. So cosine square of t plus sine square of t will give you 1. So your the x of p is simply just this. Then your final answer is equal to the combination of non-homogeneous and homogeneous parts. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.